Have you ever tightened a bolt, or used a wrench to loosen a nut? If so, you've experienced torque. Torque is simply a twisting force. It's what makes things rotate or spin. Torque is all around us, from the wheels of our cars to the hinges on our doors. It's a fundamental concept in physics and engineering. Understanding torque is important because it helps us design and control machines. By measuring and controlling torque, we can make sure things work smoothly and efficiently. So buckle up and get ready to explore the fascinating world of torque. Imagine opening a door. You push or pull the handle, right? That creates torque around the hinge and open. Think about riding a bike. When you pedal, you apply torque to the pedals, which turns the gears and ultimately the wheels. Even using a screwdriver involves torque. You twist the handle that drives the screw into the wood. These simple examples show how torque is a part of our everyday lives. It's the force behind countless actions and movements we take for granted. Now let's talk about how we measure torque. That's where torque sensors come in. They are like detectives of the mechanical world, sensing and reporting on rotational force. Torque sensors are devices that convert torque into a measurable signal, usually an electrical one. This signal tells us how much twisting force is being applied. These sensors are crucial in many applications, from ensuring the safety of cars to controlling the movements of robots. They give us valuable information about the forces at play in machines and systems. So next time you see a machine operating with precision, remember the role of torque sensors in making it all happen. How do torque sensors actually work? The magic lies in their ability to detect tiny deformations caused by torque. Many torque sensors use a principle called strain gauge technology. Imagine stretching a rubber band. It becomes thinner and longer, right? Similarly, when torque is applied to a material, it causes slight deformations. Strain gauges are bonded to the material where torque is measured. These gauges are designed to change their electrical resistance when stretched or compressed. As torque is applied, the material deforms, causing the resistance of the strain gauges to change. This change in resistance is proportional to the applied torque and is converted into an electrical signal. Section 5. Types of torque sensors. A sensor for every spin. Just like there are different types of tools for different jobs, there are various types of torque sensors, each with its strengths. Some common types include rotary torque sensors. These measure torque on a rotating shaft, like in an electric motor. Reaction torque sensors. These measure torque that's stationary or reacting to another force, like in a wrench tightening a bolt. Optical torque sensors. These use light beams to measure the twist, offering high accuracy and immunity to electrical interference. The choice of torque sensor depends on the specific application and the range and accuracy of torque measurement needed. Section 6. Torque sensors in action. Industries that rely on the twist. Torque sensors are essential in numerous industries, playing a vital role in ensuring safety, quality, and efficiency. In the automotive industry, torque sensors are used in electric steering systems, engine control, and braking systems for precise control and safety. In aerospace, aircraft use torque sensors for flight control, engine performance monitoring, and landing gear systems. Manufacturing relies heavily on torque sensors, where robots and automated machinery use them for precise assembly, material handling, and quality control. In the energy sector, torque sensors are used in wind turbines to monitor shaft torque and optimize energy generation. These are just a few examples of the wide range of industries that depend on torque sensors for critical operations. Section 7. Real-world wonders, torque sensors in your life. While you might not see them, torque sensors are silently working behind the scenes, making your life easier and safer in countless ways. In power tools, cordless drills use torque sensors to adjust the power output, preventing damage to materials and ensuring consistent performance. In medical devices, surgical robots rely on torque sensors for delicate procedures, providing surgeons with precise control and feedback. And in consumer electronics, touchscreen devices use torque sensors to detect the pressure and angle of your touch, enabling intuitive interactions. From the cars we drive to the devices we use daily, torque sensors play a hidden but crucial role in shaping our modern world. Section 8. The benefits of torque sensors. Precision and beyond. Using torque sensors offers several advantages over other methods of measuring force or rotation. First, accuracy. Torque sensors provide highly accurate measurements, ensuring the precise control of forces in critical applications. Second, feedback control. Real-time torque data allows for immediate adjustments and feedback control, leading to smoother operation and reduced wear and tear. Third, safety. Torque sensors can detect overloads and prevent equipment failure, enhancing safety for both operators and machines. And finally, efficiency. By optimizing torque levels, machines can operate more efficiently, reducing energy consumption and operating costs. These benefits make torque sensors invaluable tools in various industries, driving innovation and improving performance across the board. Section 9. Conclusion. The future is turning on torque sensors. As technology advances, the role of torque sensors will only continue to grow. They are essential for the development of smarter, safer, and more efficient machines. From robotics and automation to renewable energy and medical devices, torque sensors will be at the forefront of innovation, enabling new possibilities and shaping the future of engineering. So, the next time you encounter a machine or device operating with remarkable precision and control, remember the unsung heroes working behind the scenes. Torque sensors, the detectives of rotational force, quietly making our world a better place, one twist at a time.